Okay, so this video here is going to assist us with wiring Lab 3 here. And this potentiometer here is a 5 kilo ohm potentiometer. And the potentiometers that you have in your kit are radial ones. And the one you want to look for is one that says that it's a 502 um, on them. And remember, when we went through the introduction, you could kind of see the numbers on the potentiometers, but you're looking for a 502 potentiometer, which again, that would stand for 50 times 10 to the second ohms, which would be 50 times 100, which is of course 5,000 ohms, which is 5 kilo ohms. So that's how we know that it's a 5 kilo ohm potentiometer. Now, potentiometers have several uses. One way is to use them as a variable resistor. Basically, a resistor that, turning the knob, I get to change the value of the resistor. And the way you do that is there are three components to a potentiometer. There are three branches to it, and you connect what's called the swipe end of it to one of the other terminals here. So before we even talk about wiring it, let's maybe talk about how this works here. So basically, what you've got inside this radial potentiometer is that, let me draw that a little bit better. Not perfect, but great. Good enough. Is you've got some, like, graphite is probably what it's made from, but some kind of conductive material in there. And then you have, here I'll do these in blue, you have literal connection here, and then a pin here. So these are two of the legs of the potentiometer. And they're the two outside ones, not the middle one. And so if you put an ohm meter between these two outside legs, you'll read 5 kilo ohms. And in fact, if you just wire up these two outside legs, it just acts as a 5 kilo ohm resistor. It doesn't do anything else because you're not actually using it as a variable resistor or as a potentiometer. Now what happens is this third pin, there's a swipe here. So there's like a little metal connection here. And then there's a little dial here. Let me do that again. There's a little, and then a little dial here, and then that dial is connected up to another pin. And then you turn this dial, which then, of course, moves where this physical connection is. But now you're kind of splitting this 5K ohm resistor. So you can see here, if we measure between these 2 points here, you're only getting this portion of, for instance, the graphite. So that is going to be one resistor. And then if you measure through these 2 points, you're going to be getting this other portion, which is going to be a second value for a resistor. Now, if I tie, so that's the general way a potentiometer works. So you can get two resistors that you can vary, but you can only vary them like this might be 1K, but that means this is 4K. Because it has to add up to 5K because that's what you have between these two legs here. So you have to always add up to whatever the potentiometer is set at. And so with this one here, you have to be very careful. This particular potentiometer we have, the screw mechanism here is very sensitive, and just the slightest turn actually adjusts it. So you want to turn it very slowly with a screwdriver or any other object that can act as a screwdriver. So we're wanting to use this as what's called a variable resistor. So I'm really only wanting to use one side of this. So what we do is we connect these two together here, for instance. So this is now shorted, so we're basically ignoring this portion of the potentiometer because I've shorted these two legs together. So this portion is just gone. So I'm just going to kind of scribble it out because, well, I should be careful. Let me undo that here. This portion is gone in the sense that it is no longer really connected up to here. because we've shorted these two terminals together. But now what we have is if we connect up these two terminals, we still have a resistor value. Like again, this might be 4K, but then if I move it, for instance, if I move it now to this location, now the resistor here is only this portion. So I can move this swipe anywhere on this disk here and get different values of resistors. Okay, so let's go ahead and again do our classic here, looking at how many nodes we have in our diagram here for wiring this up. So we've got one node here. We have another node here, which actually I'll go ahead and say that's this entire node here. And then we have one more node at the bottom. All right, so we've only got a couple nodes here. And depending on the measurements we're taking here, you know, again, we've talked about different ways you could wire these up here. And so what we're going to do now is go to the Fritzing program. And you might say there's another node up over here, but there's not, because this is, again, part of my negative side or ground here. Okay, so then let's go to the Fritzing program, and hopefully it doesn't crash on us. So I've already kind of pre-built some things for us here, except yeah, it looks like this here. This is a 10K ohm. At first I didn't think I had switched that, but that is now brown, black, orange, not brown, black, red. And then we still have my 2.2 and 4.7K ohm resistor. Okay, so let's, and then here is my potentiometer. I don't think I set it for, well, it said maximum resistance was 10. I'll just set it down to 5. That doesn't actually really do anything as far as the picture goes for us. But I'll just go ahead and at least make it consistent with our diagram. So these aren't necessarily the final locations for everything. I just have everything kind of, you know, at least on the board here so we can kind of move things around. And then we've got this power supply here. So let's see here, go back to our circuit diagram and look at this first node. I always like to start at the power supply end. So what do I have connected up to that? Well, I've got a 2.2K ohm resistor. So I like to have those then to kind of be at the top here. So I'm going to move this over here. This is my 2.2K ohm resistor. So I'm going to put it kind of at the top here and move it in maybe a little bit. And then, of course, draw a wire between that and the power supply. And what I'm going to do here is change that wire color, of course, to red. So I've now placed that component on my board. And I can cross that off. I've wired that up now. Now there's a whole bunch of things that need to get wired to here. First off, notice that the 10K and the 4.7K are in parallel. They're sharing the same top and bottom. So I'm just going to go ahead and do that right now. So the 10K and the 4.7K share the same top and bottom. Okay, so that's what I've done here. And one side of the 5K is also connected up to there. But instead of trying to, you know, put this over here, I'm going to leave this off to the side here. So one side of that, now if we go back to the diagram here, this little arrow here is representing this kind of connection here. So that means the other side, this one, is the one that gets connected up to there. So what I'm going to do here is I'm going to simply say, okay, well, it's here, and I'm going to, let's see here if I can do this here correctly. I'm going to bring it all the way to the top there. And I'm going to just change that to green. You can make it any color, but I'm just doing it green because I'm making a connection between those here. Now let's see here. Where are all those things connected to? Well, they're connected to the other side of the 2.2 k ohm resistor. So I'm going to do a wire from here, whoops, a wire from here all the way to there. So the 2.2K, and I did green because I'm essentially, you kind of can almost think of it as like, well, you know, I'm just using one node, so I'll just use the same color of wire for that node. When you get into complicated circuits, unfortunately, it's not that simple. You'll just have to use whatever wires you have available. But for now, we can go ahead and color code our nodes here. So that's kind of that green node here. But let's double check it. The 2.2 needs to be connected to the 10K, the 4.7, and one side of the potentiometer. Okay, so the 2K, it's connected to one side of the 4.7, one side of the 10K, and then this wire goes to the potentiometer. So yeah, if I follow this wire, it's connected to one side of the potentiometer. All right, so I'm going to tag that out. And now let's see here. Well, there's this little wire here that I need to do, which is connecting those two terminals together here. Now there's a couple ways you could do that. You could notice that, wait, this is all one node and everything's just running to ground. So let me show you two ways we could do this. One way to do this would be to simply, whoops, that's moving the potentiometer. Sorry, just a second here. Just lost my train of thought here, and I just put a, undo that. Let me pause a second. Okay, sorry about that, and this might be jumped a little bit because the program, of course, crashed on me again while I was doing some things here. What we need to connect up here is we really just have this, if we go back to here, we have this last node we have to connect up. But what I was wanting to talk to you about here was, and this can happen sometimes, and this is probably happens if you put it, notice that this physical component is taking up a lot of these pin slots here. And you might say, well, I just can't really make very good connections here. And so what you can sometimes do to give yourself, now this is going to be a little bit over the top and a little bit, you know, not necessary to do, but that's okay, is that what we can do here is you can say, well, what I'm going to do is I'm going to, like, for instance, put a wire here, and I'm going to change this color. And I'm just going to go to purple. I like purple. Just for no other reason than I like purple. And then I'm going to go right down here for the other one. Now, this serves no other purpose than now I have 1, 2, 3, 4 more pinholes that I can now connect up to this potentiometer for each of those swipes, or for each of those pins. Because the potentiometer itself is taking up so much space that, you know, I don't have a lot of room to put wires to connect it. Well, what I do is I put a wire and connect it to another row here, because now I have 1, 2, 3, 4, 1, 2, 3, 4 other ones to connect up here. Now, this is, again, sometimes I'm going to kind of do this in a, this is definitely not necessarily the only way or the simplest way even, but I just want to show you how you can start using your breadboards to do all sorts of kind of interesting ways of wiring things up here. So we know that all of these things need to get connected to ground because that's what this node is, right? It's all connected to ground. So I know these all have to be black wires back to this thing here. Well, first off, what I'm going to do is I'm going to go ahead and draw a wire here all the way across the board here, and I'm going to make it, I just zoomed in by chance, I'm going to make this color black because that's ground. Now what I've done here by doing this, I've now made this long column that's ground, I've connected it up to this long column that is ground. Because again, you can see when I start to draw a wire, look at all the yellow that's highlighted. That means all those things are connected together now. And so what I can do now is I can just say, okay, well, I'm going to connect that because those are connected to ground. And then these resistors are also connected to ground. And so I just made a connection on those resistors to ground. And now, if I double check here, okay, the negative side of the power supply needs to be connected to the other side of the 10K, other side of the 4.7K, the other side of the 5K, and the swipe line. Okay, it's connected to the swipe line, that's the middle one. It's connected to the other side of the potentiometer, that's ground. And then the 10K and the 4.7K, yep, is connected to the other side of those. So I can tag out that wire that's been connected. So I only had 3 nodes, and now I've got all 3 nodes connected, and I can now power up my device and take my measurements as needed. So the other reason I wanted to kind of do it this way is you can kind of spread out your things. The other thing you can do here, and let me just kind of do this, and I'll do it with, if you're, for instance, wanting to measure a voltage across this potentiometer or something of that nature, you can, you know, put a wire out here, just put another wire in. Actually, we'll leave that one ground because it is connected to ground. So I'm just putting another wire in here. It's connecting to nothing, but then I could connect this up to my multimeter. And I'll go ahead and maybe put a link on, or actually, I'll do a quick search and show you an Amazon page where you can get, if you want to get a pair of test leads for your multimeter that have alligator clips, I can show you where you can get one of those relatively cheap. It's not necessary to, but some people prefer them. So I can just, you know, instead of having to try and connect up to the components, I can say, well, here's ground, I'll put that into here. And then again, let's say I'm trying to measure the voltage of a resistor here or something. So what I'll do is I'll put a wire in here and say, okay, well, I'm going to have that wire and have this wire here be, I'll just have this wire be yellow. And so now these I've plugged into the breadboard, but then what I can do is I can take my measurements from these wires, and then I could, you know, and of course anytime you want to move this wire, you should definitely turn your power supply off, but you can move it to different points on your circuit and take various measurements without having to sit there and try and, you know, get your probes into there. Sometimes that can make measurements easy. You might say, why did they ever make those probes so small and hard to use? And it's really because most things you're actually in real life that you'll be testing will already be put together. They won't be on a breadboard, and they'll already be put together in a fixed spot. So touching the positive and the negative sign will make much more sense to do as opposed to trying to clip them on, or, you know, all these resistors are bending all over the place, because in real life they're already going to be built for you. Okay, so let's end this video here. Oh, actually no, we said I wanted to show you the Amazon here, so let me go there real quickly, see if I can pull this up here. If my Amazon will load in. We might not be doing this here. There we go. The one side of them is called a banana plug. Let me double check to make sure these X-Techs don't have. Ooh. I'm going to cancel us on this here. Like this one here should work fine, but we'd have to double check here. This one should work fine, but we need to be careful and need to double check to make sure that the sizing is correct. I believe it's just a standard banana plug, but for instance, you could get them here so that, you know, it's got the little alligator clips, $10, you know, not too bad. So you could use that then on your multimeter. Alright, so yes, we're ending the video.